NCERT 9.5 NCERT exercise numerical from ray optics. A small bulb is placed at the bottom of a tank containing water at a depth of 80 centimeter. Means this is a small water tank. Okay, in this water tank at the bottom the source is small point source of light S is here, which is at the 80 centimeters depth as per the question. What is the area of the surface of the water which light from the bulb water through which light from the bulb emerge out? Here, through which area of the water surface the light emerge out? This question, whenever we are seeing, it looks different. Therefore, how it is looking different in the sense, how we can find the area? Area means the total container area will come, no. But here logic is that, the questioner logic is that when you have taken your point source, in the sense, this point source is a light. From this, the light is traveling denser to rarer medium. Whenever it is traveling from denser to rarer medium, we have an option. If light ray is traveling more than the critical angle, it reflects inside itself. If light ray is traveling with the critical angle, then it goes on the surface of the water, or along the surface of the water it emerges out. So that is the logic behind this. So for that purpose, according to the critical angle concept, we have to proceed. For that, as we have given data, refractive index of the water is 1.33 is given. As questioner said, here bulb is a point source we have to consider. So you can see here, you can, from this, I am considering this is a source, in the sense from the source the light ray can have chance to pass like this as well as like this also. Okay, whenever light ray can able to pass, it emerge out, because of if below the critical angle it can incident, but since it is incidenting with the critical angle IC, therefore it is not emerging out. If it is emerge out, it could be within this circular area only, maybe. So now, since it is emerging out with the critical angle, so it comes on the surface like this. Since it is coming on the surface, whatever the left area is there from the center of the center point to the either sides radial distance, if you take that, I am considering as a circle. This is a circular area which we are going to find. Okay, across this area the total light is emerging. Okay, so this total area is, the light is covering nothing but, I can say here. So I am considering from O to this radial distance R, and this is a hypotenuse, this is a adjacent side of this critical angle IC. From this right angle triangle, what I am taking, tan IC equal to OA by opposite side by adjacent side OS, I am writing, which is the radial distance of the circle. And since it is looking like a cone, this is the height center part I have taken, H. Tan IC equal to R by H, R equal to H into tan IC whenever I send that side. So this is, you keep aside. Now area of this circular patch, area of cross-sectional area of this circle, if you take, that is pi r square, basic formula. We know that R is a radius, which is H tan IC. So if I'll substitute in the place of R, H square tan square IC it is. Then for the tan square IC, I can write as sine by cos, sine square IC by cos square IC I have written. So cos square IC, as from the trigonometry identity, I have written cos square IC as 1 minus sine square IC. Now to find the area of cross section, I need to know what is the sine IC value. So from the given question, it is the depth, the light source is at the depth of 80 centimeters. So refractive index of this medium is 1.33. Therefore I have a sine IC equal to 1 by mu, critical angle relation with the refractive index. From that, 1 by 1.33, which is also can be written as 3 by 4. Therefore sine I is equal to 3 by 4 I can write out. This value I am substituting in a place of IC, and pi value is 3.142. H is 80 centimeter. I am writing in terms of meters. 80 into 10 to the power minus 2 meter square. So that is whole square, since h square is here, into sine square IC 3 by 4 whole square by 1 minus 3 by 4 whole square. If you simplify mathematically, we have area of that circular patch, nothing but cross sectional area of that circle is, which is equal to 2.6 meter square. This is a ray optics exercise question, which is NCERT 9.5. Thank you.